let's look at some real reactions, okay? Let's say you have the reaction of graphite with oxygen gives you CO2 gas. You can measure that in a bomb calorimeter. This is a combustion reaction. Remember, combustion reactions are reactions with oxygen gives you the oxides, right? So the oxide of carbon is CO2. That's an easy reaction to do in the lab. You can do that with bomb calorimetry. So let's say you determine that to be X. Carbon monoxide gas. You can get a tank of carbon monoxide, introduce that into your calorimeter. You can mix that with oxygen, burn it up. Okay, you can get carbon dioxide as well. Okay, that reaction can also be measured in the lab. So let's say you can measure that. You found that to be Y. Okay, so those are known. Now, I want to know, based on these two numbers, can I calculate delta H for this? This one gives you graphite plus oxygen to yield carbon monoxide. Now, why might I have trouble doing this in the lab, actually measuring the delta H for this reaction in the lab? The reason is, anytime you have burning carbon, okay, there's a possibility you're going to get carbon monoxide or carbon dioxide, and if you don't have enough oxygen, chances are you're going to get a mixture of carbon monoxide and carbon dioxide. There's no way you can say that I'm going to control the amount of oxygen and just get carbon monoxide. You'll always get a mixture. Okay, some of the carbon might be left unburned if you don't have enough oxygen. Okay, so that's very hard to control. It's very hard to control whether you're going to get. It's very hard to just say you're going to get carbon monoxide. But how can you guarantee that you don't get carbon monoxide? Like this one. I told you earlier, this one's easy to do in the lab. You can guarantee that all your products are carbon dioxide, that there is no carbon monoxide by using a large excess of oxygen. Okay? So in a bomb calorimeter, you use a large excess of oxygen. You're not going to get carbon monoxide. You're going to get carbon dioxide as a product. So this can be measured easily, this one can be measured easily, but this one cannot. But you can figure out the delta H for this reaction based on these two. How are you going to do that? Let's see. Imagine, okay, my goal is to get a reaction where I start off with graphite, 2 moles of graphite, and 1 mole of O2, and end up with 2 moles of carbon monoxide. Well, which of these two reactions up here has graphite on the left-hand side? A mole of graphite on the left-hand side. This one, right? So maybe what I can do is I'll imagine burning graphite so it becomes carbon dioxide. So I'm going to say my first reaction would be graphite plus O2 gas gives me carbon dioxide gas. But I need 2 moles of graphite. So what should I do with this reaction right here? Double it, multiply all the coefficients by 2. What's my delta H for this one? Well, the delta H for the original reaction with just 1 mole each would be X. So if I double all the coefficients, what's my delta H for this one? It's going to be equal to 2X. All right? Now I'm going to say, okay, I don't want carbon dioxide. I want carbon monoxide. I want carbon monoxide as a product. I want this on my product side. So what should I do? Well, I made my carbon dioxide from the first step, right? So now I'm going to imagine that the reverse of this second process actually happened. It's not going to happen, but I can imagine it happening. What would be my delta H for that? It's just going to be the negative of this one, right? So if I flip that, I'm going to get negative of the original delta H. Okay, I want to make 2 moles of carbon monoxide, so that's good. I want to make 2 moles of carbon monoxide right here. So I'm going to flip that second reaction. I'm going to say, I'm going to change my 2 moles of carbon dioxide. 2 moles of carbon dioxide. I'm going to flip that reaction to give me 2 moles of carbon monoxide gas plus O2 gas. And so the delta H for this second step is going to be negative Y. because the delta H for the original reaction is Y. I just flipped it, right? So let's combine these two reactions. Now, does that give me the overall reaction I want? Well, I've got two graphites right here, two graphites right here, and I've got the two carbon monoxides up here, right? What happens to my CO2? I made 2, I lost 2. So CO2 does not appear in the overall reaction. What happened to my oxygen? I started out with 2 moles. I ended up with 1 mole, so that means I've lost 1 mole. So that's just 1 mole of O2 left. So I got the reaction I want. So the delta H for this reaction is equal to what? 2x plus negative y, which is just 2x minus y.